Okay, we're going to work on your law and sines, sines, and cosines and fundamental identities quiz review I gave you today in class. I went over most of these problems in class, but just in case you missed something or you want to see something worked out again, this is a good idea to watch this. And that's pretty much what you're doing if you are watching this. You're trying to get a better idea of what's happening here. So I'm going to go over these questions here. On the quiz tomorrow, I will give you this formula table on the top here. So we're going to work out number 1 here. So let's get started. I have two fractions here that I want to add together. So I need a common denominator. The idea of this is trig verification, is to make one side equal the other side, only manipulating one side at a time. So what I'm going to do here is I'm going to get a common denominator on these two fractions here. So I'm going to multiply this one right here by the other one, which is tangent x plus secant x. So I'm going to say tangent x plus secant x. I'm going to do that top and bottom. And here I will multiply this part right here by the other one, which is tangent x minus secant x, and do the top and bottom again. Okay. All right, so I'm going to say we got 1 here times this, and I'm going to distribute this 1. Okay, so I got tangent x and then secant x. That's what I'm going to get out of that. Plus secant x. All right, that's the top. And here I got 1 times tangent, which is tangent, and 1 times negative secant, which is negative secant. All right, and we got a fraction here and a plus sign, so we're going to add two fractions. Now I have to figure out what the denominator is. All right, it's worth noting though that I have this times this. This is kind of like a difference of squares. These two are conjugates. So what I'm going to say then is I'm going to multiply this out. I'm actually going to work this out just so you can see what's going to happen, even though you have an idea already, or you should. Okay, I'm going to FOIL all this step by step. So I'm going to say tangent times tangent. I'm going to put it over here. Tangent times tangent is tangent squared. Tangent times tangent is tangent squared. Now I'm going to do tangent times negative secant, which is negative tangent secant. I'm working out every step so you can see what's happening. I have secant times tangent. All right, it's positive, so it's going to be positive tangent secant. And then I have a secant times a negative secant, which is now negative secant squared x. This is a negative tangent secant and a positive tangent secant, so these actually cross out. So what I get out of this is tangent squared x minus secant squared x. That's what this times this is. So it's going to be tangent squared x minus secant squared x. These are the same things over here, so I'm going to get the same thing on the bottom over here. Okay, so from now on, I'm actually not going to FOIL all this out. I'm just going to say, hey, this times this is what this is, and you have to know. So I have a common denominator now. These are the same, so I can write it as a single fraction. Okay, I'm going to say the bottom is going to be the denominator tangent squared x minus secant squared x. I'm going to say, okay, I'm going to combine the top. So I got tangent x here plus another tangent x. So tangent x plus tangent x is 2 tangent x. That's what I'm going to say they are. I have secant minus secant, so these will just cross out. These are nothing, so that's what I have. Okay, now I have to keep in mind, you have to keep an eye out for what you're trying to get here, which is a negative 2 tangent x. I have a positive 2 tangent x right here, but that's not what I want. I want a negative 2 tangent x. So if I divide 2 tangent x by negative 1, that'll give me the answer that I want. So it kind of hints to me that the bottom here should equal negative 1. That's what's supposed to happen. All right. Now, I have a tangent x here. Let me change my color here. Okay, I have a tangent squared x right here, and I notice right here in my table up here, I have a tangent squared x plus 1 equals secant squared x. So I'm going to rearrange this equation right here. Okay, I'm going to rearrange it and say that I'm going to subtract 1 from both sides of this equation. So what I'm going to say then is that tangent squared x is in fact the same thing as secant squared x minus 1. I just subtracted 1 from here and from here. So I can see here that this tangent squared x is the same as this tangent squared x. So I'm going to take this secant squared x minus 1 and substitute it into here for tangent squared x. Okay, that's what I'm doing. So I have 2 tangent x now And here on the bottom, I'm going to have a secant squared x minus 1. And then I want to subtract the secant squared x after that. What's going to happen now, finally, if I change the color again, is that I have a secant squared x and a negative secant squared x. They're going to cancel out. What I have left on bottom is negative 1. So I got a 2 tangent x divided by negative 1, which is negative 2 tangent x. So negative 2 right there. So this is actually your what? This is your solution here. So it's proven. All right, this problem is done. All right. So let's go on to the next question. Number 2. All right. Let's go back to red here. Okay. So I'm going to work with the left side and try to make it like the right side pretty much. I can see if I turn everything into sine and cosine, it's not a bad idea. I have sine squared x, all right? So I'm going to say sine squared x. It's already in sine form. Times secant squared x. Secant squared x is actually 1 over cosine squared x. That's what that is. Now I have a plus sine squared x. Oops, this is jittery on me. Times cosecant. But cosecant is the same thing as 1 over sine. So cosecant squared is 1 over sine squared x. All right. So what's going to happen here is if I multiply these out, I got sine squared x over cosine squared x plus sine squared x over itself. Sine squared over cosine squared is tangent squared. Okay, sine squared over cosine squared is tangent squared. Sine squared divided by itself is 1. All right, it goes to 1. This right here that I have now is a trig identity. Go back up here. Tangent squared x plus 1 equals secant squared x. So tangent squared x plus 1, this is actually equal to secant squared x. It's a Pythagorean identity. So this right here, of course, is the answer. So this is done. Pretty simple problem. Number 3 was the hardest problem on this paper. And I really wasn't satisfied with the way I had worked it out in some other classes here. So kind of want to be careful with this one. I did end up working this out a certain way, and then a student in class during my second period figured out another way that was even shorter. So I'm going to work it out the way that she had done it, and then I'll work it out the way I did it. So if you are satisfied with the way I do it the first time, you don't have to watch that part of the video. You can fast forward through that and go on to the next question. All right. So I'm going to let's keep my blue pen. I'm going to work with the right side and make it look like the left side. Okay. So this is what was done by the student. This is the process she followed. So I'm going to do the same one for your viewing pleasure here. So say this: we have sine of x. Okay, sine of x. I'm going to rewrite this over this. I have a fraction here, and I have 1. The denominator is sine of x. 1, though, can be written as sine of x over sine of x. Okay. This sine of x divided by itself is 1, so it's the same thing. And now I have minus cosine of x over sine of x. Okay. And here, I'm going to say cosine of x. And we have the denominator of cosine, so 1 can be written as cosine over cosine minus sine over cosine. Remember, 1 is the same thing as cosine over cosine. Same thing here. So now I have a common denominator of sine and sine, and a denominator here of cosine and cosine. They're common. So I can actually rewrite this now as sine of x over sine of x minus cosine x divided by the common denominator, which you can see here is sine. All right, and now I'm going to add. I have cosine of x, and I have here, we're going to combine the top. We have a common denominator right here, so we already have, cosine on the bottom. But we're going to say this is cosine x minus sine of x right here, all over the common denominator of cosine. So this is what I have here. Okay, and as you can see here, what's going to happen is this is kind of like saying sine of x over 1 divided by this fraction. Right? So when you divide by a fraction, you're going to multiply by its reciprocal. So what I'm really getting here, and let's change this to red maybe we won't get these little slash marks, is I'll have a sine of x, okay, times sine of x over sine of x minus cosine of x. Okay, I'm just multiplying sine here by the reciprocal of the bottom. That's what I'm doing. So we're just flipping the bottom fraction. That's what we get. All right, we're going to do the same thing here. We're going to multiply cosine of x by the reciprocal of this, which is cosine of x over cosine of x minus sine of x. All right, so what we're going to do here is distribute. So sine of x times sine of x is sine squared x over sine of x minus cosine of x. And then we're going to get plus cosine of x times this is cosine squared x over cosine of x minus sine of x. All right. Now, I don't have a common denominator here, and I still have to add these two fractions. But I can see this is sine of x minus cosine, and this is cosine minus sine. So, this is kind of what was throwing me off. But what was this? What was the process that was done here? This was done by a student, actually. Was we're going to actually multiply this by 1. But instead of calling it 1, we're going to multiply this by negative 1 over negative 1. Okay? This has the effect of switching this the way I like it. So I say negative 1 times cosine will be negative cosine squared x. And then negative 1 times this, it'll flip the sign. So cosine will become negative and sine will become positive. So that's going to give me a positive sign instead of the negative that I had, and a negative cosine. What I notice now is that this is sine minus cosine, which is the same as the denominator here. So now I have a common denominator. Sine squared x over the common denominator of sine x minus cosine x. So this can now be written as a single fraction. All right. So now I have sine squared x minus cosine squared x all over the common denominator, which is sine of x minus cosine x. All right. The last step here, which takes a little intuition from Algebra 2, is to be able to factor this. This is like a difference of squares, okay? So to give you an idea what I'm talking about, it's like in Algebra 1 and Algebra 2 where they say a squared minus b squared, which is a difference of squares. See the difference between two squares here, a squared and b squared, and here's the difference between them, is the same thing as a plus b times a minus b. All right, that's an actual thing that you learn in Algebra 2. And we have that going on here. We have a square and a difference between them. So we could actually write the top of this equation as sine of x plus cosine of x times sine of x minus cosine of x. Same thing that I'm doing here. It's like a plus b times a minus b. And this is going to be over sine of x minus cosine of x. And what we can actually see then, using this difference of squares property, is that now that we've done this, we can cancel out this with this. All right, so that's gone. So all I have left now is sine of x plus cosine of x. And as you recall, because sometimes it's easy to get lost as we do this, that's what I wanted. All right, it's the same thing. Okay, so we're done technically with this problem. That's a check. All right. Now, as I said before, that is not the way I worked it out, and what I worked out was quite lengthy compared to this, but I'm going to go ahead and do it anyway, in case you're interested. There's more than one way to get to the answer, and the way I did it was a little more difficult compared to what the student did. So I just showed you the way the student did it. This is pretty straightforward. I probably will not give you a problem this difficult on your quiz tomorrow because I don't want you to spend too much time on any single question, because it's not supposed to take all of class time. So if you don't want to watch me do this again, then go ahead and fast forward through this part of the video, but I'm going to go ahead and work it out again the way I had done it. Alright, so I'm just going to extend my page here and do the whole thing over again. Alright, actually do that. So I want to call this 1 minus cotangent, pretty much is what I want to say. Alright, so this is going to be sine of x over 1 minus cotangent. Same thing. All right. And this is going to be plus cosine of x over 1 minus tangent x. Now what I'm going to do instead is multiply this here by its conjugate, which is 1 plus cotangent. And this one here, and top and bottom, same thing, right? Which is what you could try if you have a 1 minus something. You could try to multiply by 1 plus something and see if it works out. And then we'll do the same thing here, 1 plus tangent instead, and 1 plus tangent here. Okay. Alrighty, so this is what I'm going to do. I'm going to multiply this out. Change this up. We're going to distribute the sign. So we're going to say sine times 1 is sine of x. Sine times cotangent is sine cotangent. Alright. And this part will be over this, which is another difference of squares, which is 1 minus cotangent squared x. And then plus, we're going to distribute this. This is going to be cosine x plus cosine x tangent x all over this times this, which is a difference of squares, which is tangent squared x. Very well. Now I can see that I don't have a common denominator, so I'm going to have to multiply again. So this is a two-step process for me. This is why this was a little lengthier. I'm going to have to multiply this denominator by this one. That's what I'm going to do. So I'm going to say 1 minus tangent squared x top and bottom. Okay. So this turns into a bit of a marathon problem. And here we're going to multiply this 1 minus tangent squared times 1 minus cotangent squared. So this is the part where, you know, people start seeing this is going to be kind of laborious and they don't want to continue. They're like, oh, I'm going to stop. It's not worth it for me, right? But you really can't be like that in a lot of mathematics. You're going to have to struggle through it. So we're going to have this. We're going to say sine times 1, which is sine. Sine times this, which is negative sine tangent squared x. Then we got this part here. Okay, we're going to say all of this sine cotangent times 1. Right? So this is going to be plus sine x cotangent x. And then we have sine and cotangent times negative tangent, okay? And I'm going to go ahead and write that out, even though I don't really need to, just to show you. That's actually a minus. Let me erase that. Okay, let's see. Yep, there we go. This is going to be a negative, okay? A negative sine times cotangent times tangent squared. Okay, and this is going to be all over this times this. All right, so I got 1 times 1, which is 1. 1 times negative cotangent, which is negative cotangent squared x, sorry. And negative tangent times 1, which is negative tangent squared. And then we got negative tangent times negative cotangent. Tangent and cotangent are reciprocals. So if you multiply them, you'll get 1. So I have basically a negative tangent times a negative cotangent. So negative times a negative is a positive, but this times this is 1, so it's plus 1. That's essentially what I have. This is only this left side. That's what all of this is. Crazy enough, right? So I say, okay. Now what I'm going to do is multiply this side. Do the same thing I just did on the left side to the right side. I know it's really seems really awful now, right? So we're going to say, all right, cosine times 1. I'm just going to write underneath here is cosine. Cosine times negative cotangent is negative cosine x cotangent x. All right, now we're going to do this times 1. So this is going to be plus cosine x tangent x. And then this times negative cotangent, which is negative cosine x tangent x cotangent squared x. All of this over the same thing. I have this and this. It's going to give me the same denominator as the one I just had from here and here. It's the same multiplication. So it's 1 minus cotangent squared x. I'm just copying this bottom here. Minus tangent squared x plus 1. Okay. And remember, what I'm doing with both of these is I'm adding them together. I'm adding this whole thing right here to this whole thing right here. Okay? But now I have a common denominator, so I can add stuff pretty much. So let's see what we can get out of here. Let's just kind of write stuff. So I can write this as a single fraction. That's the idea, because I have the same denominator. So I'm going to say sine of x plus cosine of x. I'm going to write it over here. Sine of x plus cosine of x. All right, so let's just cross out when we've worked through them. So we got this and this. Okay, and the next thing I'm going to look at is I have a sine and a cosine, and I want to get as many of these as I can, okay, because that's what the answer is that I'm looking for. So I can see right away, though, a couple things that are going on in my problem, like right here. If I look at this right here and this right here, this is what's going to happen. This is like saying sine, and cotangent is basically cosine over what? It's cosine over sine. And I have that times sine is pretty much what I'm doing, so I'm going to cancel all this out. What happens, though, when I multiply these is these signs are going to cancel. So this whole thing really right here is the same thing as cosine. Here I have cosine, and it's being multiplied by tangent, which is the same thing as sine over cosine. All right, so this is kind of the same thing here. Cosine will cross out with cosine. So what I actually have again here is a cosine plus a sine. All right, so it's sine of x plus a cosine of x again. All right, and all of this is accounted for. And all of this is accounted for. That's what happens. Okay, so I need to keep going through this. That one was done again. Let's not use purple. Let's use. Let's go back to blue, I guess. Okay. So I can see here that I have a sine times a cotangent here, right? I have a sine times a cotangent here, and that's going to happen. The same thing's going to happen here. I have a sine of x times a cotangent x, which is what? Which is cosine over sine. And don't forget it's multiplied by tangent squared. But these signs cancel, right? So this whole part right here is like saying, it's like saying cosine times tangent. So it's like saying negative cosine times tangent squared x. It's kind of what that's saying. Here I have cosine times tangent again. So I have cosine of x times sine of x over cosine of x. Right here, times what? Times cotangent. So these cosines cancel. So it's like saying sine of x times cotangent x. So it's like a negative sine of x cotangent squared x rather. So negative sine of x cotangent squared x. It's like that's what this whole thing is saying right here. Okay. Now I have here a negative sine x and a tangent and a negative cosine and a tangent. So I'm going to combine these two by factoring out the negative out of both and the tangent out of both. So what's going to happen is I factor out the tangent squared x, the negative tangent squared x. So this negative is out and this tangent is out. This negative is out and this tangent is out. What I have left is positive sine and positive cosine. So this is times positive sine times positive cosine is what this really is. Okay? And here I'm going to do the same thing, all right? This cosine times this cotangent here. All right, so is that a sine squared? That should be a squared. Let me see. Let me make sure. That's cosine. Oh yeah, that's right. That's what happened. This was a cosine times a cotangent, so that should have been a cosine cotangent squared x. That's what that is. That's where I was messing up. All right, so that's what that is. Here and a negative sine here. So we're going to factor out a negative and a cotangent out of both. A negative and a cotangent out of both. So this is quite tough. So this is a negative and a cotangent squared x. We're going to get rid of the negative and the cotangent squared out of both. A negative and the cotangent squared out of both. Because that was a square, mind you, right? And now we have what's left is a positive cosine and a positive sine. So this is multiplied by sine of x over, plus positive cosine of x. This is all this going on here. And now we're going to say 1 plus 1 is 2 minus cotangent squared x minus tangent squared x. And lo and behold, I'm almost done, but I can see stuff here. And this was quite a difficult way that I went about doing this compared to what was done earlier. But what I'm going to see here is now I have sine plus cosine, sine plus cosine, sine plus cosine, sine plus cosine. I can factor that out of every term because it's in every term. So basically I'm going to say this is sine of x plus cosine of x factored out, and I'm going to divide every one of these terms by sine of x plus cosine of x. So if I divide it by itself, I get 1. So that's 1. If I divide this by itself, I get 1. So that's plus 1. If I divide this by itself, this is going to give me negative tangent squared. And divide this by itself, it's going to cross it out. This is going to give me negative cotangent squared. I factored out the whole thing. So keep in mind, sine of x plus cosine of x times 1 is this. This times 1 again is this. This times negative tangent is this. This one right here times the negative cotangent is this whole thing. I just factored it out. And all of this is over 2 minus cotangent squared x minus tangent squared x. But if you notice, this is 1 plus 1, which is the same thing as 2. And then we have a negative cotangent and a negative tangent there. Okay. What's going to happen after all that, good grief, is that this is going to cancel with this. And all that is left is what I factored out, which is sine of x plus cosine of x, which is your answer. So this is the way I did it, which is horrible, I know, but it took me a lot longer than to do what the student did here. So in this case, yeah, I got outsmarted. I mean, admittedly. So, but good for them. I won't give you a question that hard though, and we're going to move on to number 4. All right. So let's do that. Okay, number 4. Didn't leave myself much room here, but let's take a look at it. This is not a hard question right here. Let's just write this out. I know that sine squared, if you remember your trig identity, sine squared x plus cosine squared x equals 1. That's a Pythagorean identity. So what I'm going to do really is subtract cosine squared x from both sides of this equation. So I'll say then that sine squared x is actually equal to 1 minus cosine squared x. And because I have a sine squared x right here, I'm going to use this and substitute it in for this. So what I now get is a tangent squared x times 1 minus cosine squared x. Okay? Alright, and this, of course, I'll now distribute this tangent into here, because I can only work with the left side. That's what I'm working with. So let's do that. So tangent squared times 1 is tangent squared. And tangent squared times negative cosine is negative tangent squared x cosine squared x. Okay? I will remember, of course, though, that tangent squared x is actually the same thing as sine squared x over cosine squared x. That's what this is right here. Times cosine squared x, which is the same thing as cosine squared x over 1. And what I see, of course, is something's going to happen. The cosine squared x's will cancel. So now what I have now is simply tangent squared x minus sine squared x. But I just told you that this sine squared x is the same thing as this, which is actually equal to what? 1 minus cosine squared x. Right? So what I'm going to say now is that this is equal to tangent squared x, okay, minus 1 minus cosine squared x. So now I'll distribute the negative in here. So this will give me tangent squared x, and then a negative times, okay, so this negative here times a negative is a positive cosine squared x, and then a negative times 1 is a negative 1. So this right here is actually the same thing as your what? As your answer. Okay. And now we'll move on to the last two. Okay, we're finally on the last few questions here. So let's go ahead and get this done. We have two fractions that are being subtracted, so we need a common denominator again. So I'm going to multiply this denominator by this one. So I'm going to say, okay, 1 minus cosine times 1 plus cosine. And we're going to do the top and bottom by that. And then over here, same thing. We're just going to say what? 1 plus cosine times 1 minus cosine. And then top and bottom, the same thing. All right. Okay, so let's go ahead and do that. What we're now going to do is multiply these out. Okay, this times this and this times this. Okay, so if I multiply this top by this top, if I FOIL it, in other words, it's going to end up being 1 plus 2 cosine x plus cosine squared x. If I multiply this by this, if I FOIL it, in other words, I'm going to get 1 minus cosine squared x. That's what's going to happen. And then I have a minus. And I'm going to multiply this by this. And that's going to give me 1 minus 2 cosine x plus cosine squared x over this times this, which is the same as over here. It's 1 minus cosine squared x. So we have a common denominator now, which was the whole idea. I'm actually going to go ahead now and take this negative sign and distribute it. It's really important that you do this part, because if you don't, it's going to mess everything up. So negative times 1 is negative 1. Negative times negative 2, of course, is positive 2, and then the cosine of x. And negative times cosine is negative cosine squared, right? This right here. So we're just going to say, okay, we're just going to go ahead and add instead of trying to subtract all that. It's the same thing. We're going to add all these negatives here. So if I say then, what is 1 minus 1? These are going to cancel. Cosine minus cosine cancel. So now I have 2 cosine plus 2 cosine. That gives me 4 cosine x. All over the common denominator here, which is 1 minus cosine squared x. Okay, keep in mind, using my trig identity, which says that sine squared x plus cosine squared x is in fact equal to 1. That means that sine squared x is equal to 1 minus cosine squared x. This is what I have right here. So this is the same thing technically as sine squared x. So I'm going to rewrite that. It's 4 cosine of x over sine squared x. This, of course, is going to be the same thing as 4 over 1 times cosine over sine times 1 over sine. So if I say 4 times cosine times 1, that's 4 cosine. If I say 1 times sine, that's sine squared. Understand these are the same thing. 4 over 1 is 4. Cosine over sine is cotangent. And 1 over sine is cosecant. This, of course, is your what? It's your answer. That's what that was. Okay? So that's how you do that one. And we're on to the last one, where we have a quadrilateral. All right, so it says part A, calculate the length of AC. So here I am from point A to point C. So this is what I want. I want this diagonal. And this is a right triangle. So this is a very easy thing to find. We use the Pythagorean Theorem. We basically say that 3 squared right here plus 3 squared is equal to AC squared. So this is 9 plus 9, which is AC squared. So that means AC squared is equal to 18. Well, that means that AC is equal to the square root of 18, because I don't want AC squared, I just want AC. The square root of 18 is the same thing as the square root of 9 times 2. 9 times 2, it's a multiplication. The square root of 9, of course, is 3, and then we have what's left inside the square root is 2. So we can say this is the same thing as 3 root 2, if you want. Okay, you can plug this into a calculator, and I'll probably do that just to see what happens. I'll just say 3 root 2. That's basically 4.24. All right, so that's what I'm going to say it is. Or it's 4.24 if you want. Okay, same thing. About. So I'm just going to call it 3 root 2 myself. All right. Now, that's what that distance is right here. They calculate the area of the triangle ACD. So they want ACD. They want this triangle up here. They want this area of this triangle. Okay. The area formula for triangle is A is equal to 1/2 BC sine of A. I gave you that on the top of the front page. Okay. So if I call this angle A, because that's the only angle I want, this will be little a, which means this is little b and little c. So all I need is BC. So I'm going to basically say that this area is 1/2 3√2 times the other side, which is 4.5, times the sine of this angle 25 degrees. Same thing as 1/2 BC sine of A. Okay, and I'll make the calculator tell me what that is. So let's take a look. First thing I want to do is make sure, however, that the calculator is in the right mode and not in radian mode. I want it to be in degrees. So the first thing I'll do is I'll go to Dock, I'll go to Settings and Status, and I'll go to Settings, General Settings, and make sure this is in degree mode. So I say, okay, yeah, it's good to go. So I'm going to say, all right, let's multiply then. We'll do 1/2 times 3√2 times 4.5 times the sine of 25 degrees. This will be 4.03 is what I got for that area. So I'll go back to that and I'll say, okay, that's about 4.03 square centimeters. Okay, 4.03. The area of the quadrilateral ABCD. ABCD. All right, this is a whole thing. All right, I want the whole thing, area of the whole thing. I already know the area of this part. I just need to find the area of the other triangle and just add the two together, and then I have the area of the whole thing. So we'll just find the area of this right triangle, which is pretty easy because the area of the right triangle is 1/2 base times height, and I know that the base is 3 and the height is 3, and this is a right angle. So it's basically 1/2 of 3 times 3, which is the same thing. I'm sorry, this is 1/2. This is not 3, it's a half. Okay, half. 3 times 3, which is 9/2. So I'm going to basically add 9/2 to this other area, and that will give me this answer. Okay, 9/2, of course, is 4.5. So this is going to be 4.5 plus 4.03. So this is going to equal 8.53 square centimeters. That'll be your answer. So this is the area of the bottom triangle, the area of the top triangle, and that's your answer. All right, so this whole thing is done. Not such a big deal, but I hope you practice it. Like I said, this is one of the more difficult parts of the course, but you'll be fine. And thank you for watching.